This is chapter 3, transformers and single phase induction motors. In this chapter we will study about various types of transformers and various types of single phase induction motors. The unit outcomes of this chapter will be to understand what is the construction and the working for the different types of transformers, what is the EMF equation and the transformation ratio, what is the construction and working of a single phase AC motor, what are the different types of single phase motors, and what are their applications. So after studying all this, we will get a general understanding about the types of transformers, the types of induction motors, their working, their construction, and the applications that are associated with the types of transformers and single phase induction motors. Total marks allocated for this chapter are 14. The legends R, U, and A. R is remember what you are studying so that you can write the answers. U is understand the concepts which you are studying so that you can write your answers properly. A is apply your remembrance and understanding of your concepts for the theory as well as your practical. What are transformers? A transformer is a electrical device which transfers electrical energy from one electrical circuit to another electrical circuit. It can be a single circuit to single circuit transformation, or it can be a single circuit to multiple circuit transformations. Now it is a passive electrical device. Passive means you have to supply some form of electrical energy to the transformer. It will not generate electrical energy on its own. The transformation that is being done will have no change in frequency, means the input frequency of the electrical circuit on the input side of transformer will be same as the output frequency of the electrical value on the output of the transformer. The transformers, they can also used for isolation. So here the voltage that is being given as input to the transformer will be the same or equal to the output voltage that is being taken at the output of the transformer. Here separate coils are there. These are not electrically bounded to each other, means you will have two separate electrical coils. One will act as an input coil and another will act as an output coil. There are following types of transformers: step up transformer and step down transformer. Step up transformer means the electrical voltage that is being given as input will be stepped up. Stepped up means the value will be increased. Example, if you are giving a input value as 420 volts, in a step up transformer it can be increased to more than 420 volts. Step down transformer, in a step down transformer the value of the output voltage will be less than the value of the input voltage. Example, if you are giving 420 volts as the input, you can step it down up to whatever minimum value you require. Second type is three-phase transformer and single-phase transformer. Three-phase transformer means you have three live wires. Live wires means these three wires will have the electrical voltage value in them. The single-phase transformer is you have only one single live wire, means only one wire or a one phase with live electric circuit. Third type is electrical power transformer, distribution transformer, instrument transformer. Electrical power transformers means they are used in power transmission. Distribution transformer, it is used as a distributor in electricity. Instrument transformers, which are used in various instruments. Fourth type, two winding transformer and auto transformer. Two winding transformer means you have two windings. One will be acting as a input side and the second one will be acting as a output side winding. So the first input will be the first winding and output will be the second winding for the two winding transformer. Auto transformer, you have a single winding that will act as the input as well as the output. The fifth type is outdoor transformers and indoor transformers. A single phase transformer. Let us understand what is a single phase transformer, what is its construction, what is its working, and its applications. A single phase transformer is a type of transformer that utilizes single phase alternating current. That is, the transformer relies on a voltage cycle that operates in a unified time phase. So what is a voltage cycle that operates in a unified time phase means the value of voltage at a particular instant in a alternating cycle will remain same. The ratio of the primary windings to the secondary windings of the transformer will determine the change in current. If the number of windings on the primary side and the secondary side are the same, the current value will remain same. If you want to increase the current, you will have to decrease the number of windings on the secondary side. If you want to increase the current, you will have to decrease the winding, and if you want to decrease the current, you will have the increase the winding on the output side. Why it is there? Because you have that equation I is equal to V upon R. I is current, V is voltage, and R is resistance. In the transformer, the value of voltage will remain constant for the input side and the output side. The value of resistance will remain constant on the input side and the output side because the material will be the same, and the voltage that is being taken as input, it will remain same, and even if it changes, still the output voltage will remain same. So the current can be changed by changing the number of windings on the output side. So what is the principle of single phase transformer? It works on the principle of Faraday's law of electromagnetic induction. What is Faraday's law? It states the mutual induction that is between the primary side and the secondary side of the windings. Typically, mutual induction between the primary and secondary windings is responsible for transformer operation in electrical transformer. So we know what is mutual inductance. When we supply a current to the coil on the primary side, as you can see in figure, the primary winding is wound on the core. When we supply electricity or voltage to the primary winding, it generates a flux in the core. This flux will travel to the other side where there is a secondary winding. This flux will be responsible for generating a induction value on the secondary winding side or the output side. This is called as mutual induction. So the single phase transformer works on the principle of electromagnetic induction, mutual inductance between the primary winding and the secondary winding. Construction of a single phase transformer. As shown in figure from slide 4, a single phase transformer has an iron core, also called as the iron limb. It has two windings, one on the primary side and other on the secondary side. The two windings are wound cylindrically on the iron core. This iron core provides a path for the flow of magnetic field, which will induce voltage on the secondary side winding. As you can see in the figure, the two windings are not close enough to have an efficient magnetic coupling. What it means is the magnetic field that is generated on the primary side, it will not be transferred 100% on the secondary side of the winding. This is because there is loss when the flux that is generated on the primary side is transmitted to the secondary side. Thin steel laminations can be used to prevent the losses from the core. The core can be laminated with the help of thin steel sheets so as to stop the losses. Based on how the windings are wound around the central core, the transformer construction can be divided into two parts, or you can have two types of transformers. First one is a core type transformer and the second one is the shell type transformer. The figure A shows a core type single phase transformer. Here it has a central core which is made up of iron, also called as a transformer core. The core is wound by two different windings or two different limbs. The primary winding and the secondary winding on the output side. Primary winding has n number of turns called as Np. It has primary current called Ip, and it has a primary voltage called Vp. The secondary turns has n number of turns called as Ns, secondary current denoted as Is, and the secondary voltage denoted as Vs. So here two coils or two windings, they will surround the two different limbs of the core. Figure B shows a shell type single phase transformer. Here the main difference is both the windings are wound on the central core or a single limb. Here the other part of the core will surround the windings. As you can see in the core type single phase transformer, the core does not surround the windings, but the windings are wound on two different limbs of the core. And in the shell type transformer, windings are wound on a single side and the other part of the core will surround the windings. That is the major difference between the two.